Okay, I'm pretending like I didn't stop talking for 3 days, and we are back at this point. The degree of polynomials, the last thing we were talking about is what exactly that implies. And the degree of polynomials is simply the sum of the, oh, damn it, the largest sum of exponents of variables in any one term. So, x plus 7. What's the exponent that's with the variable in x plus 7? What is the exponent that is with a variable in that binomial? 1. So that has a degree of 1. Okay? X squared plus x plus 2. What is the degree there? No, just 2. Degree 2. Because you go to the largest sum of the exponents with variables. So there's only one variable with exponents. It's got a 2. Everybody good? Okay, so that's a degree 2. X squared y plus 2xy plus 3. What degree is that guy?
3.
Right. That is a degree 3 because 2 plus 1 makes that the third degree. Everybody cool? The only use it has is this. We put the biggest degree thing first, or the biggest, or it's alphabetical. Okay? I don't care. You guys have enough on your mathematical plate with doing the actual math before I'm going to care if you write it in the right order or not. Are you with me? Everybody cool? That's only, I'm showing you that because as you go further and further into math, they start caring more and more about crap like that. Okay? So I want you to have seen it, but I don't care. Understand? All right. Now, I also don't care about algebra tiles, which you may or may not have used in the 9th grade. These things, oops. 1, -1, x, -x, x squared, -x squared. Have you guys seen those? I don't ever want to use them ever again because they're not for intelligent folk. Okay? They serve one purpose, and one purpose only, and it's to explain why subtracting a negative is the same as adding a positive. It's the only thing they're good for. Otherwise, they are useless. So I am not going to use them. Okay? So everything you see that's concrete or pictorially, we're not going to do because you already know how to do it. Actually, you might not, but you'll know how to do the thing with math. And then I would have to take marks away from you for not being able to do something that was invented to help people who can't do math, even though you can do the math. Do you understand how silly it is? So I'm not going to show it to you. We are going to skip right to algebraically. And what we were doing was this, 5x plus 1. All of you already know how to multiply that. What is the answer? 5x plus 5. All of you automatically know how to do that. Now explain to me why. Because you have to multiply the terms outside the bracket times the terms inside the bracket. So really what this is 5 times x plus 5 times 1, which is 5x plus 5, right? Some of you will have had teachers draw these arrows in here to show that it is happening. And some of you will have even had teachers that have called it flying arrows, which I despise. Because that's not what it is. When you go to university, your university professors aren't going to say, well, now you have the flying arrows, the little 4 into the brackets. They're not going to have a little cute story about how the 5 is a knight that wants to break into the castle and 5 is that was me sticking this pen into my eye because I hate it when people tell stupid little stories like that about math. I've told you about my grade 7 teacher who told me to remember that the hypotenuse of a triangle is called the hippopotamus and then marked me wrong when I put that on a test. Had he just said it's a hypotenuse, I would have remembered it because that's a word. And as you can plainly hear, I speak English. I did not need to know that it was a hippopotamus because it's not a hippopotamus. It's a hypotenuse.
Isn't hypotenuse Greek?
Yes, but we use it in English. Anyways. It's a pain in the ass. I don't know how you women walk around with this
I
stuff.
love long hair.
Oh, it drives me up the wall. And it's hot. Although it's probably because it's made of polyester and your hair is made of hair. That's probably part of it.
That's actually what it did. It's actually made of candy.
So. All right. The distributive property is this. I'm going to write it out with letters because this is what it really is. A, B plus C is AB plus AC. Now here's the thing that messes kids up. This is not a formula. Okay? It is a method. All right? So if it was 6 times x squared plus 3x plus 7, you would have to do 3 different distributions. All right? It must go to all 3. You already know this. This is not news to you, but there's a couple of other warnings. What if there's a negative out in front? What does that do to B and C? Then the answer is going to be negative AB minus AC. The negative will change everything inside the brackets. Okay? Again, not news to any one of you. You all saw that in the 9th grade. So, that means it should take about 2 seconds to do just the algebra solution to these two. No drawings, just tell me what the answer is here when you distribute that x into the brackets. And then you can do the same thing down here. So what is this one?
2x squared minus 4x.
2x squared minus 4x. You guys sounded like evil twins on a movie. 2x squared minus 4x.
She said it. She's supposed to say it like 2x minus 4x.
Okay, and what's this one?
3x squared.
3x squared plus 6x. All right. Son of a gun. So everyone remembers the distributive property, right?
Yeah.
And all of you at least went that far in the 9th grade. A monomial times a binomial. Right? You all went that far in the 9th grade. Yes? Okay. Now,
Well, we did this one.
did you do binomial?
Yeah.
All of you.
Yeah.
Okay? So this, of course, is, x has to multiply by x and 2, and then plus 3x and 3 times 2 to get x squared plus 2x plus 3x plus 6. Collect your like terms, x squared plus 5x plus 6. You guys have all seen that too, yes? And you all know that FOIL stands for first, outside, inside, and last, right? So if we draw it out, x plus a, x plus b, it is first x times x. There's the f. Then x times b. Then that's the o. Then inside x times a, and then out there's the I, and then the L is A, B. Right? Not news to anyone, yeah? Okay. So, all of you can write this out and figure it out. Now, I'm going to do something here that maybe your teacher didn't do in the past. You probably don't even need me to do it, but it's useful as we go further along. Hopefully, many of your teachers showed you that when they wrote it out, they probably wrote it one of two ways. They either went x squared plus 4x minus 4, and then told you to collect your like terms, plus 3x minus 4, right? Or maybe they showed you this move, x squared plus 4x, new term, write it on another line, and line up your like terms. Then just add them up. 4 minus 1 is 3x, 0 minus 4 is negative 4. Hopefully you saw one of those two things. I like this way better because eventually you're going to be doing trinomial, right? So it can get very confusing if you try to line it all up horizontally. Everybody cool? I don't care what way you do it. It's your math. You do whatever works for you, okay? And hopefully your teachers also showed you this funky shortcut, which was x squared, and then you add, and then you multiply. So you get negative 1 plus 4 is plus 3x, and negative 1 times 4 is negative 4. Hopefully they showed you that as well. Now the problem with this is depending on how far your grade 9 teacher wanted to go with multiplying binomials, if he stopped here, or she, then this is lovely. But you guys aren't stupid. You're well aware that this x here doesn't necessarily have to be a single x, does it? Which makes this little trick of add and multiply not the greatest thing to have in your math toolbox if you're not aware of how to actually do it. Do you understand what I'm saying? Everybody cool? All right. So you guys don't do anything that's pictorial. Just do it algebraically. All right? So this next page should take about a minute. No, I lied. It should take a little longer. Do page 4 right now. Well, for me, it's page 4. I don't know what page it is for you guys. Is it page 5? Oh, it's because your outline is part of the printing. I got to remember that. So all you got to do, you do not, no pictures. Just tell me what the answer is. And I'll wait like 30 seconds while you guys do this page. It'll take slightly longer than 30 seconds. You don't have to draw the algebra tiles. Anthony, don't, please. Unless you really need to, you don't have to.
But we've choose the entire page.
All right, again, no rush. Please just check up, make sure you've got the right, you've got this. I know that you all do. Answers are highlighted. Everyone okay? Please notice this first one, I actually wrote it out, but of course I would have just done my own little shortcut there. And there's that one. That one. There's no need for that second bracket. I don't know why I put it there. 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 And there and there. Does anybody need to talk about any one of those? Or are we okay with multiplying polynomials? You're going to get a buttload of practice at it. I'm not incredibly worried about it. I know you did it to death in the 9th grade. So is everyone okay? Everyone is good? C? Well, because that would be x squared minus 2x plus 3x minus 6. Negative 2 plus 3 is 1x. Everyone okay? Once, twice, thrice? What are you laughing at me for? I look like an idiot because I'm dressed in a costume, I know. Well, what else am I going to do with it? It's in the way. All right. Okay, guys, this next page, you should have the next page. The font is, believe it or not, mathematics boredom for me. You do not have to do that page right now. Okay? And actually, because trig took longer than I was expecting it to, I'm actually not going to have you do any textbook work on multiplying. Okay? So all you're going to do is, I'm going to shut up in a moment. Okay? I'm going to shut up in a moment, and I'm going to let you guys do, for you, pages 5, 4, and 5, which should be 2 pages of polynomial multiplication. Yes?
6 and 7.
6 and 7 for you? What do you guys have after this?
7.
Oh, this is 5. Yeah, I'm one behind you. You're one ahead of me. Right.
Yep.
So you guys do pages 6 and 7. And then we're going to see where we are. Okay? If, depending on the time, when we've gone through them all, but that means you got to work. I'd like to go on and do the first lesson in factoring polynomials. Okay? So you guys do these couple of pages first. I'll be putting up the right answers, and you will mark it in a moment. Okay? Go.
He's quite long. Like, he's like, maybe.
What are you talking about?
My snake.
Oh. What? Why?
You gotta do like the whole like flip though.
It's too big.
Earlier today, I had to tie it up so I could eat.
Oh, we should do like
Actually, quite a few pirates do that.
Huh?
They tie their hair up.
we should braid it.
That'd be annoying.
It's already in sections.
Wait. There.
Did you just stick up like a pencil in it?
Oh
Yeah.
wow! What? It's actually.
I have daughters.
Yeah, I know.
I can do a very little bit with hair.
I have
My
daughters.
dad. Well, I only have 4. There's 4 girls in the family. Well, 5 including my mom.
That's impossible.
Wait.
Remember, you don't have to draw
My
anything.
dad can braid hair.
My dad can do.
Like, he knows how to
But
braid
not
hair,
very
and he
well.
can put it up in an okay bun, and it looks fine in a ponytail. It's okay. But my dad's pretty good at doing hair. But then again, he only has daughters. So. I keep drawing an X so funny.
That's not X.
Okay, no, I do an X, and then I do a swerve, and then I go to cross it, but then I just
It's a
can't.
fancy X, so that's like I do the straight across one.
Never mind. Oh, what's that? D went 2 times 1.
Next year, I wanna actually do something.
Wait, it's 2 still. Are we adding the exponents when they're in here? It's last block. It feels like.
Oh, you want?
I keep
Yeah. So it feels like it's lunch. Oh yeah.
It's not.
It feels like it's lunch.
I hope it doesn't rain the entire night. Mike, you're walking because it's just gonna smear. Did you get 6-3? Okay. 8x squared.
My mom feels bad.
1 minute.
She just bought me candy. She's like, oh, you can't go trick or treating. But here's a bag of candy. Like, it's good enough. You just want the candy.
Can't go get the water.
I like this new way of doing it. This is quite easy this way.
Which way? The ed.
No, the like the adding way that he's doing.
Oh.
It's so much easier than like collecting like terms.
Yeah.
I just said like.
You said a lot of likes there. You sounded like Shaggy.
Shaggy says like.
He says that?
Scooby-Doo.
Yeah.
Like
Oh, yeah.
Yeah, I guess.
Scoob.
Oh yeah. I didn't realize how many times they said like in this.
The most used, according to Tom, the most used word is cringe in the 2016 cringe. I don't know.
What? According
Okay,
to
according to my friend, she
That's
said
just cringe.
the most used word 2016 right now is the word cringe. I don't know why, because everyone, I know it's used, but I don't see it.
Okay. I notice a lot of people standing around, so that first page must be done. Now listen up, please. Listen up, please. If you have yet to figure out this fact that I'm about to say, then you're really going to be in trouble as we go along. This stuff that we start every unit with that seems drop dead easy has led to stuff that has caused all of you grief because you are not actually mastering this stuff because you figure you've got it down. Okay? This page, the first page, should have taken about 45 seconds to do the whole page. That's how long it should have taken. Okay? If you are taking longer than 45 seconds, then you are not where you need to be with this. And the fact that you are not actually practicing it bothers me. All right? I gave you 2 pages to do. I gave you a couple minutes to do it. You should already be done both of them, but you're not. Oops.
What'd you get for email? Oh, you're not there yet. Okay. I should just do this one. It bothers me that whiteout's not the same shade as paper.
Well, is it that paper's not the same color as white?
That's just an exception. Well, like, why don't they make whiteout the same shade as paper so you don't even notice it?
Because not all paper is the same.
Most paper is a white though, not yellow. Makes me sad.
Turn on the yellow. What's it called? Paper tape. Let's see how it's taped up.
Oh, your way is so much easier.
What would you?
Can I use the paper tape, please?
You're doing it so weird.
You.
It's yours.
Okay, 2, 1 squared minus 8, 1 plus 2. We have minus 1 third minus 1 line. 1 single line. So minus 2 times squared.
And then, when you get to the end of page 7, you see M and N. You all, from the 9th grade, know how to handle M and N because you already know those exponent laws. Kind of. You probably don't remember them. And we're going to be doing a unit on exponents because there's some new stuff that you will not have been taught about exponents before. So you may leave M and N alone right now. Unless you want to try them. Feel free.
Don't do that. Don't.
Yeah, makeup makes you your face itchy. That kind of makeup, I hate it.
It's like a wax. It's like Crayola.
Yeah,
It's like I put crown.
Yeah, you melt it and you're just like.
yeah, I hate it.
It's like cheap dollar store face.
Yeah, that makes it even worse.
Actually, the one I bought really long time ago, it was actually pretty good. But it was something else.
Oh, that's what I was doing.
All right, is everybody okay with all of these?
It's negative. Yes.
Remember, I do not care if you want to write it all out in a line and then collect your like terms, or if you want to stack them like I do. I don't care. Your method is your method. You do what works for you. A lot of kids haven't seen this the way I write it before, and they see it and they like it. A lot of kids see what I do there and say, that's not the way I learned to do it when I was in the 9th grade, so I'm never going to do that. And I don't care. It's totally up to you. Whatever works for you. I find this to be easier when doing a long expansion. Okay? But you're big kids, you can make your own mind up. Okay? Is everybody good with polynomial multiplication to at least a competency level? Meaning you're able to get these answers. I don't expect you to be as fast at it as me. I don't care, that's fine, as long as you're able to get the answers. Everybody good with multiplication of polynomials? Remembering that this is grade 9 stuff. I need you to be good at this so we can do the grade 10 stuff. Some of which you may have, again, seen. It depends on who your teacher was. I don't know. Do we need another moment with it? It's fine with me. I don't care. I got the time. Okay, finish it off. Make sure you've got the answers up here to check them against. Oh, and please, guys, you saw how fast I did this, and I did it all in my head. If I've made a computational error and you notice it, do not feel bad about telling me, okay? I am not a computer. I make mistakes. Just like you do, yes. That one? Okay, that squared means that the whole base multiplies by itself again, right? So that becomes x minus 4 times x minus 4. Now I used the shortcut. I added them, negative 4 to get negative 8. Then I multiplied them to get 16. But if you're going to write it out the long way, it's x squared minus 4x minus 4x again. And minus 4 times minus 4 is plus 16. Then you add it. X squared, negative 4 minus 4 is negative 8x. 0 plus 16 is positive 16. The mistake most kids make with that is they want to tell me it's x minus 16. Because you vaguely remember in grade 9 something about that exponent going to both of those. Everyone can multiply? Okay, how about this? If you're concerned about your multiplying of decimals, my son was multiplying decimals yesterday, so I was working on that with him. Sorry. If you're concerned about your multiplying of polynomials, page 186 has plenty of work on it. You're welcome to go and use it. Okay, but I'm not going to come around and check because it's grade 9. It's multiplying. Everybody good? All right. So everyone's cool with multiplying? Okay, now I want to do something a little different than we're used to doing. Has everybody marked their work?
No.
Okay, make sure you get your work marked. It's all recorded anyway. You can check it at home. But the next page in your books should say factoring polynomials, doesn't it?
Yep. In a weird font.
Yeah, that's bomb font. I don't want to go into that right now. I want to do some background to that before we go any further. So if I could get everyone to do one of two things. I'm going to remind you of some old school, like when I say old school, I mean like grade 5 math. If you feel you're okay with it, just watch what I'm going to do and pay attention. If you feel that maybe you're not so hot with your grade 5 math, you want to have a scrap piece of paper out just to scratch down anything that I may write on the board that you may have forgotten or want to, please do so. Because what I'm about to do isn't in your notebooks right now. It's a reminder of some old school stuff. Okay? So it's up to you. I'll leave it up to you to decide how you wish to proceed with what I'm about to do. And remember, you can go back and check your polynomial multiplication tonight or something like that. So, if I were to give you the following fraction, remember, this is review from a long time ago, so you decide if you need it or not. If I were to give you the following fraction, what would you do with that? If I just put that on a page with this instruction. What would you do? Manru? Divide by a common something. A common something. Not a multiple. The other way from multiples. Factors, right? This is 3 times 7, yeah? And this is 8 times 7, yeah? And 8 is made up of 2 times 2 times 2 times 7, yes? And you see that 7 is the biggest number that they're both shared by, yes? So you would take 21 and divide by 7 and 56 and divide by 7, and you would get 3/8. And your teacher, Mrs. Bad Crumble in grade 4, would have said, you have just reduced the fraction, wouldn't she? Or he, right? That's what they called it. It's not reducing, it's the same fraction. It's simplifying. Everybody all right with that? We all remember doing that? The other thing I want to remind you of is this. If I ask you to add these two things, what would you do? Now, Andrew. Yes, a common multiple, because you would need a denominator of 35, and that would be 21 plus 15, right? Right? So you're all already familiar with two very important concepts to high-level math, and that is the greatest common factor, GCF, and the lowest common multiple. You know these from simplifying fractions, and this is from common denominators. Now the problem is many math teachers don't give you these two terms, greatest common factor and lowest common multiple. They tell you to reduce a fraction and they tell you to find a common denominator. So when you come to higher level math that requires you to use GCFs and LCMs, you're like, but if I show you this, you're all like, oh, it's 35, right? And when I showed you this, all of you are like, oh, it's 7, right? Okay. This is what the rest of this unit hinges upon. Factoring, okay? So I just want to remind you of a few things about factoring. First of all, again, you may not need to write this down. You may want to write down part of it. You may want to write down all of it. You may just want to watch the video later. It's fine. This is all review. You already know it. A factor is something that's multiplied in regular English. Okay? So 3 times 7 equals 21. What are the factors in that equation? 3 and 7. These guys are the factors. And that allows us to make this statement. The numbers, the integers, 3 and 7, are factors of 21. Are there other factors of 21? Yes. What are the other factors of 21? 1 and 21. 1 and 21 are factors of 21. Are there any other factors? Not integers, right? Not whole numbers. Yeah? Everybody cool? Everyone remembers this, right? Yeah? Okay. Do you remember doing this? If I ask you to factor 16. Do you remember ever doing that in elementary and or middle school? Okay, how would you handle it? I need to know, because I need to know how you guys were taught to do this is going to affect how I teach you to factor polynomials. You follow me? So what would some of you do if you were faced with that question on a test from Mrs. Bag Crumble in grade 6? What would you do? You'd do the tree? All of you would do the tree? Every single one of you would do the tree?
Yeah.
Yes? I need to know. I'm not trying to be a dink. I need to know.
Yeah.
Yeah? So you would all go, you would split this into something, right? Most of you would probably go 2 and 8.
Yeah.
And then you'd break 8 to 2 and 4. Then you'd break 4 to 2 and 2, and you'd probably stop. Yes? Okay. That is not what I need you to do with this unit. That does something totally different. Okay? That is what we call prime factoring. And we're going to get into that later because it's going to play a very important role in another unit. But in this unit, I'm not looking for all the factors. In this unit, I'm looking for pairs of factors. Okay? So I'm looking for branches on the tree. 2 times 8, a pair of factors. Is everyone cool with that? So what I'm actually looking for from you in this unit, if I say factor 16, I'm actually looking for this. 1 and 16, 2 and 8. I'm looking for the pairs. Everybody cool? Yeah? So if I asked you to do this, what? Oh, right, 4 and 4. Thank you. 4 and 4. Thanks. If I asked you to do this, factor 72, in this unit, I'm looking for the pairs, right? So we'd have 1 and 72. 2 and what? 36. 3 and 24. 4 and 18. 6 and 12. And 8 and 9. Cool? Now, I obviously am picking a number that I use all the time. That's why I'm able to rock it through that. I'm not a brain surgeon, okay? I'm a pirate. Because remember, you were asking if I was a pirate, and I said I was a brain surgeon? Never mind. Okay? I've just practiced this a lot. So, to do this unit well, you're going to want to be very good with your times tables and your divisibility rules. Do you guys remember those? Your teachers gave you a million little rules. If it ends in 0, 2, 4, 6, or 8, it divides by 2. If the numbers add up to a number that divides by 3, the whole number divides by 3. If it divides by 2, it'll divide by 4. Like all that crap, right? You didn't know that one? Case? Okay, stop. 732. 7 plus 3 plus 2 equals 7 plus 3 plus 2 equals 12. 12 divides by 3. So since 12 divides by 3, 732 will divide by 3. You guys hadn't heard? You guys don't know that? Really? Well, you know a bunch of those tricks. The 9 times table, everything adds up to 9, right? The teachers, or the knuckle thing. All that garbage, right? All that garbage. Okay, well, see, here's the thing. You guys had teachers that taught you all those silly little hand things, right? And you still do it, because when I say, what's 9 times 7? 63. And you think I don't see it, but I know what you're doing. Or worse yet, your hands are down here and I see your biceps moving as you count your fingers. I know what you're doing. It's okay. But you never learned the useful things? Because learning all those silly tricks was not useful. But divisibility rules are a real help. You guys don't know that one? No, it's not, Elma. Because your brain is more than capable of memorizing the times tables without any of this.
I remember it, but I have to go in order again.
I still have it.
All right. Okay. That's one. Here's another one. If it's even Oh, no. I remember what it is. If the last two digits divide by 4, the whole thing divides by 4.
Yeah.
For dividing by 4. No kidding. Yeah, it also works that way. It goes downwards as well. So that's the divide by 4, right? Divide by 5, what's the one for divide by 5? 5 and 0. So see, you know some of them. 6. If it divides by 2 and divides by 3, it'll automatically divide by 6. There's one for 7, but I can't remember it. I'm sorry, guys, because I actually know my times table, so I don't know any of these rules.
The 7 would be nice. I can't do my 7.
So, okay. All right. So are we all okay with this? We can all do this? Okay. So if I ask you for the GCF of 18 and 72, how would you find it? It's 18. Of course it's 18. Because 18 is 1 and 18, 2 and 9, 3 and 6. And 72 has 18 right there. Right? Now there's another way to find GCF that I'm going to teach you in a later unit. But for this unit, this is what I need you to be able to do. Everybody cool with it? Okay, now, if you get it with numbers, do you also get it with letters? You should technically, right? Right? Okay, so if I have A times B and B times C, what is the common factor there? B, right? Because these are both factors, and B is shared in both of them. Does everybody understand that? So what if I had this? X, Q, Y, and X, Y, Z. What is common? The X and Y. Is everybody good with that? Yeah? Okay, now I'm going to add one more layer to it. What if I had 18XY and 9XZ? What are the common factors? 9 and X. Is everybody still cool? Yeah? Everyone still good? Okay. What if I add this? 18x cubed y and 9x squared y. 9x squared y. Everybody good? Why is it only x squared when this has x cubed? Because the other guy only has 2 x's to cover. Is everybody good with that? Yeah? 100%? Okay. Now, I'm going to change one more thing. I'm going to make this an expression. Now what would you do with it to make it simpler? Knowing that we just did a whole couple of pages on polynomial multiplying, what do you think I'm going to do here? I'm going to divide. By what? I'm going to divide by 9x squared y. And I'm going to rewrite it, 9x squared y. What is this answer? What's 18 divided by 9? 2x cubed divided by x squared. X, y over y, gone. Plus 9 divided by 9, gone. X squared divided by x squared, gone. Y divided by y, gone. So it's 1. That should be bordering on new to many of you. But the math we did to get there, we knew all the way along. Is everyone cool? Many dabs. Yes. Dab, dab, dab. Right? Many dabs. Because that's a lot of math. And you knew it all already until I added that plus sign, and then a bunch of you figured it out anyway. Are you all cool with that? That is where I need you to be going forward in this unit. Is everybody good with it? Really? Yeah? Awesome. I don't mind doing a couple more just to make sure. Should I do a couple more?
Yeah.
If you've got it, you've got it. If you don't, just check it out. Okay?
Don't even, girl. Don't even. Don't. Someone try. Don't. Try.
So if I want you to factor that, what would you do? So you know that 6 goes into all of them. How many x's? 1 x. Because this guy only has 1 to give, right? How many y's? 2, because this guy's got 2 to give. 6x, y squared, x. Now, this part comes out here, and the answers go in here. X, y, plus 2y minus 3x. Got it? Because 18 divided by 6 is 3, x squared divided by x is x, y squared divided by y squared cancels out.
Oh, I think we did do
Everybody good?
this. Yeah.
Tiffany? Yeah. Everyone's okay? Yeah? Jazz Carrot? You're not Jazz Carrot. Yeah, you are Jazz Carrot. What? Oh, on the other one? Because when you cancel that out, when you re-multiply this, if you don't write a 1 there, you're not going to get this 9x squared, are you? Okay? Everybody good? Yeah? Okay, now, I structure this way so I get that question asked right now. Because when I show this, that should make you aware that what we are doing here is the reverse of the 2 pages we just did, isn't it? Right? The 2 pages we just did was multiplying these in here. That background I just gave you was dividing that out of here. Understand? Now, obviously, I haven't taught you how to get a binomial out of a polynomial, but we're going to go there. Understand that it is simply the reverse of what you already know how to do. It's kind of like saying, can you all add my pile of apples and Christina's pile of apples? Yes, which means you can also subtract them. Everybody understand?
Yeah.
Everybody's with me?
Yeah.
Okay. I'm going to stop. I'm happy with where you guys are.